Okay, this video, a series of videos, will show you everything you need to know about fractions for National 5 level. Going to do a wee mind map first, just as a wee introduction on things that we're going to cover in these series of videos. So, fraction. I'm going to say to you, what is a fraction? So we'll explain what a fraction is. And we'll look at the different parts of it. Okay, in terms of fractions, we can have two. We can have proper fractions. Again, we'll explain what that is. And we can have improper. And we'll have a look at that as well. We'll probably cover these three in this video. And within improper fractions, we have some techniques that we need to know about. Improper fraction, we can call that a top-heavy fraction as well, and that'll become clear why it's called top-heavy. That's another name for it. And an old name for it is a vulgar fraction. You probably won't see that anymore. It's usually these two, improper or top-heavy. I quite like top-heavy because it's obvious why it's called top-heavy when we come to see that. So, other things we'll have to do is we'll have to look at basic operations of fractions. Basic operations. And that's the four main operations: add, subtract, multiply and divide. And we'll show you techniques for doing that. When we're doing the operations, we'll show you picture format. We'll draw wee pictures. And then, hopefully, once I saw the wee pictures a few times, we'll show you a method, a structured method for dealing with these operations. Within proper fractions, we have other things as well. Really important, equivalent fractions. Now, equivalent fractions are fractions that are the same. They look different, but they're actually the same. And improper fractions, they have the same idea as well. We can do equivalent fractions for them. And why would we want equivalent fractions? Well, we want equivalent fractions so that we can do some of these basic operations, especially for add and subtract. We can only add or subtract fractions that have the same denominator, the same bottom part, i.e. the same size in the denominator. But again, we'll come back to that as we go through it. Okay. And now within top heavy and improper, there's techniques we have to know, and the techniques are going from a thing called a mixed fraction to top heavy. So we'll have to be able to do that, and going the other way as well. We have to be able to go the other way. And I think that's everything we sort of need to know about fractions. Okay, so there'll be quite a few videos in this section. So what is a fraction? So we can easily deal with that in this video. Equivalent fraction, I think we'll do that as well, and draw a wee picture as well. So we'll use pictures. And we have to simplify fractions, I suppose, as well. So within there, just the operation of simplifying a fraction. All these things we have to be able to do. Okay. Right. So let's look at what a fraction actually is. So I'll get rid of these wee bits. We'll have a wee overview of what the fractions section is going to be all about. So let's look at a few wee bits and bobs. So what is a fraction? Oh, a proper fraction then. Right. So let's just put that back in. Proper fraction. Well, a proper fraction is a fraction that's less than 1, has a value less than the whole. So we don't have the whole thing, we have a fraction of it, part of it, a bit of it. Okay, so here's a typical fraction, 2 over 5. What does that actually mean? Well, I'm going to use the bar modelling to represent how we can write 2 over 5 as a picture. Well, that 2 over 5, using the bar modelling, well, if we have one whole bar and we split it into 5 equal bits, now they have to be equal bits, and I shade in 2 parts, then that's what 2/5 represent. 2/5 of the whole thing. Okay, so the 5 is called the denominator, and the top part is called the numerator. Okay. Now, the denominator tells you how much the whole is split into, how many equal parts the whole is split into. So that's the number of parts we have for that represents a whole. So there were 5 equal bits for the whole. And the top part, the numerator, tells you how many we're actually dealing with. We're dealing with 2 out of the whole 5. Okay, so that's quite an important concept that you have to be really familiar with. The denominator tells us how much the whole is divided into, and the top tells us how many we're actually dealing with. Now, we're going to talk about an equivalent fraction. Can we write something down that's similar or exactly the same as that? Well, we can. If I take the whole bar again, it's the same whole bar as up here. I've split it into 5 equal parts. Okay. Well, if I divide it now, each bar, if I half each bar, now they'll have to be the same size, right? So these are meant to be the same size. But if I have half of the 5 that I've got there and I've half them all, then I now have 10. And the 2 bars that I had up here, well, I've halved them, so I've now got 4 of these. That's one of them from up there. Because I've halved them all, I've now got 4 of them. Now, if we think that is a bar of chocolate, if I have the exactly same bar of chocolate and it has 5 equal bits and I eat 2 of them, and the same size of bar of chocolate, if that's cut into 10 smaller pieces and I eat 4 of them, I've ate exactly the same amount. So this is called an equivalent fraction. So the 2/5 and the 4/10 are equivalent. They're the same. Now, without drawing a wee picture, can we get a wee connection between the 2/5 and the 4/10? Well, we look for a thing that you should have already covered in first year. What have they got? What do we have to do to the 2 to get to 4? What do I have to do to the same thing I have to do to the 5 to get to 10? 2 times 2. 2 times 2 is 4, and if I times by 2 here, it must be the same number. That gives me 10. So these 2 things are the same. I could cut the 10 pieces I've got there, cut them in half each, and that would give me 20 pieces for the same bar of chocolate, same size of chocolate. Well, if I 2/5 again, how do I get to here? And how do I get to here? Well, 5 times something gives me 20, so that'd be times 4 this time. I times this by 4, so that's 2 times 4. I get 8. And that's exactly the same again. And we can do that with any fraction. Take any number, multiply top and bottom by it, and we get an equivalent fraction. So that's the term equivalent fraction. Okay, so equivalent fractions are really important when we come to add and subtract. We can only add, subtract fractions that have the same denominator. Okay, but we'll come back to that later. So let me just go through that again. Let me change a number and do another example for you. Let's look at, I don't know, a third. There's a third. So in terms of the picture, here's my whole bar. And if I split it into three equal bits, now equal, remember, got to be equal. Remember what the 3 tells me. The 3 tells me that my whole thing that I've got is split into 3 parts. That tells me how many parts we've cut the whole into. And I only want to deal with one part of it. So there's one part. So that's 1/3. Okay. So can I write down another equivalent fraction to a third? Well, I can take the same bar, and there's my thirds. If I half them, well, that means I've got 6 of them now, because I had 3, and I've half every one of each of the squares. I've now got 6 of them. And that one that I had, well, that takes up 2 of these, because I've halved them. So that would be 2 out of 6, representing exactly the same thing. So we can say that a third is equivalent to 2/6. And again, the 6, we could half them. If we half the 6s to make them 12s, how many do I need in the top? How many would I clip in the top? Well, it would be 3 times 12 gives me, 3 times 4 gives me 12. 3 times 4 gives me 12. That means I need 4 times 1, and that's equivalent. And I just keep going with that. So if I take that and times it by 5, I get 15. Times the top by 5, 5 over 15, that's equivalent. Okay. So equivalent fractions, that's equivalent fractions, so I think I've done enough of them. Simplifying a fraction. Well, we've said that these things are exactly the same, so let's look at simplifying a fraction. Simplifying a fraction. Well, simplifying a fraction is going the other way. Sometimes we can simplify a fraction, sometimes we can't, but certainly all these can be simplified, because we're saying that all these are equivalent to a third. Third can't be simplified, it doesn't have, the 1 and the 3 don't have anything in common apart from number 1. So let's see how we would simplify these. Well, it's just simply going backwards. So if I've got 5 over 15, well, we'll look for what they have in common, and it's the highest common factor. So highest common factor, so you should have done that in first year. What's common to 5, common to 15, and what's the highest number that's common to both, without dividing into it, without leaving a remainder? But the highest common factor is 5. So 5 into 5 goes once, 5 into 15 goes 3 times. Third. That's a simplified the fraction. Let's take 4 over 12. Let's simplify that. So we look for the highest common factor. Highest common factor between 4 and 12. Well, that's just 4. 4 into 4 goes once. 4 into 12 goes 3 times a third. As we already know, because we know all these are equivalent. Let's try ones that we haven't used yet. What about 4 over 28? Well, we'll look for the highest common factor. Hopefully you know that the highest common factor is 4. 4 into 4 goes once. 4 into 28 goes 7 times. So that's equivalent to 1 over 7. Let's try something a wee bit harder. 8 over 30. Highest common factor. Well, 4, 8, 2. Factors of 8 are 1 and 8, 2 and 4. Well, 2 even numbers, so we certainly know 2 can go into it. So let's try 2. Hopefully 2 is the highest common factor. 2 into 8 goes 4 times. 2 into 30 goes 15 times. 4 and 15 don't have any other common numbers, so that's it simplified. Let's try, I don't know, 12 and 15. Highest common factor goes into 12, 1 and 12, 2 and 6, oh, 3 and 4. So 3 goes into 15, 3 goes into 12. So let's try 3. 3 into 12 goes 4 times. 3 into 15 goes 5 times, 4/5. That's how we simplify fractions. Okay, well, I think I've done enough of that. You get plenty of practice that in class. Okay, this is just a wee summary of all the important things you need to know about fractions. So we're doing a proper fraction. A proper fraction, remember, proper fraction is a value that is less than the whole. Okay. So let's look at improper fractions. So let's do the improper fraction over here. Improper. Well, that's a fraction that's more than the whole. For example, let's just try 1 and a half. Well, 1 and a half, you can represent that as a picture, as a whole bar, then another half of a bar. Okay, probably a wee bit too big, something like that. So that's 1 whole bar plus another half a bar. And we could cut that down the middle to say we've got 3 bars. That's about 3 half bars. That's half a bar, half a bar, half a bar. So that's 3 halves we've got there. And if you think about it, 1 and a half is 3 halves. Yeah, that's 1 whole. That's 1 whole bar. And there's 2 halves in that. And there's half a bar here. So that's 1 and a half. 1 whole bar and a half a bar. That's the same as 3 halves. Okay. Now, we talk about top heavy fractions. So an improper fraction is the same as an improper fraction. Now, looking at the wee picture here, I've got 3 halves here, so that's like 3 halves. So these two things are the same. 1, 2, 3, and it's halves we're talking about. That's why it's called top heavy. The number at the top is bigger than the number on the bottom. Top heavy fraction. In the olden days it was called a vulgar fraction, but I don't think we'll use that term because you don't hear much of it now. It's always these two terms that you hear. Now, this fraction up here, 1 and a half, it's called a mixed fraction as well. It's an improper fraction, it's also called a mixed fraction. That's another term. You can see why it's called a mixed fraction. You've got a whole part and a fraction part. So what we're saying is 1 and a half is exactly the same as 3 over 2. These two things are the same.
Oh yeah.
So we're looking at 1 and a half is the same as 3 over 2. So these are equivalent. These two things are the same thing. They look different but the same, but again, referring back to the wee picture, you can see that they're the same. Sometimes we want to go from here to here, and sometimes we want to go from here to here. How do we do it? What's the way of doing it? Well, if we look at this wee bit here, there's a nice wee connection to get to here, and I'm going to explain that to you. Okay, so I'm going to go from a mixed fraction to top heavy. And why do we want to use this? Why do we want to do this? Well, this will help us when we come to multiplying and dividing fractions. We need to have them in this format, or it's a lot easier when we've got it in this format. So for multiplication and division of fractions, we want to be able to do this type of idea. Well, this is how it goes. 1.5. Well, that's going to give us, we want to do 2 times 1, so 2 times a whole number, 2 times a whole number, plus the top number. So 2 times 1 is 2, plus the 1 at the top, that gives us 3, and what we're talking about? We're talking about halves. Okay, I'll do another one for you because it'll be a wee bit confusing. So to change this mixed fraction into a top heavy, well, that's going to give us, maybe just put a wee arrow in here rather than equals, 5 times 2, so the denominator times the whole part, 5 times 2 is 10, plus the top part is 13, so we've done 2 times 5 plus 3, and all that equals 13 over 5. Okay, so 2 and 3/5 is exactly the same as 13 over 5. Try one more. Let's go for 4 and 2 over 7. I want to put that into a top heavy. So 7 times 4, which is 28, plus 2 is 30. So that's 4 times 7 plus 2, which is 30. So that's 30, and we're talking about sevenths. So 30 over 7. Okay, that's how we do mixed fractions to top heavy. But what happens if we want to go the other way? Because sometimes we want to have top heavy and we want to go back to a mixed fraction. Well, we just simply do the division, which is going to be quite straightforward. So I think I'll keep these ones here, and I'll do top heavy to mixed fraction. Okay, so I'm going to take these and get back to 1.5. Well, got 3 over 2. Well, all we do is we simply do the division. That's 3 divided by 2. 3 divided by 2. So let's do that. 2 into 3. Well, 2 into 3 goes once, and we've got a remainder 1. But that remainder 1 is a half, because we're dividing by 2, so it's 1/2. So that's 1, and the remainder was 1, and it's in terms of halves because we're dividing by 2. Same idea for the next one. Let's 13 over 5. Let's put that into a mixed fraction. Well, we'll do the division. That's 5 into 13. 5 into 1 doesn't go, so 5 into 13 goes twice. And I've got remainder 3. But what is that remainder 3? Well, it's going to be 2 whole parts and 3/5, because the remainder is in terms of fifths, because we're dividing by 5, so it's 3/5. And let's do the last one. 30 over 7. Well, that's 7 into 30. 7 and 3 doesn't go, 7 into 30 goes 4 times, remainder 2. But what is that remainder 2? Well, it's 4 whole parts and 2 7s, because we're dividing by 7. And that's us. So, in this wee video, we've talked about what a fraction is, and a proper fraction and an improper fraction. Proper fraction being less than the whole, improper being more than a whole. We've talked about equivalent fractions, how is one fraction equivalent to the other. I've drew wee pictures to represent that. And we've showed you another way of doing equivalent fractions without drawing a wee picture. We just multiply top and bottom by any number we like to get an equivalent fraction. We have talked about the improper and top heavy fractions, and we've showed you in the wee picture here how 1.5 is exactly the same as 3/2, which is 3/2. And we've talked about how they're the same. We talked about the mixed fraction, which is the whole part and the fraction part, and we've made it top heavy. And these two things are exactly the same. Again, we're referring back to the picture. We've showed you how to mix, do a mixed fraction to a top heavy using the wee rows. And we've showed you to go in back the way, which is simply division. And that's all the basic tools that you need to be able to do fractions, to be able to add fractions, subtract fractions, multiply and divide. And you've got to be very good at everything that we've just done there. We have to have a solid base for you to be able to add and subtract fractions. Okay, so in the next video I'm going to show you how to add fractions, and we'll show you in terms of wee picture format, the bar model, and then we'll show you a structure that we can take the picture away and we can just use our maths structures to write it down rather than drawing pictures all the time. Because if you've got a fraction that's 19/30, you don't want to be drawing that picture, huh? Take ages to draw that picture. So we need some other tools so that you might have a wee picture of it in your head, but you don't want to draw it, but you want to use tools and mathematical tools to be able to add and subtract these fractions quickly. Okay, that's the end of the video.